Here the question is, use the integral test to decide if the following series converges or diverges. So I've put integral test here so you guys can remember. There are three conditions. Suppose that f is continuous, positive and decreasing on the given interval 1 to infinity. So let's say our an is this in the question, 1 by 3n minus 12 power 4. So using an, we can write it in the terms of x to write the function 3x minus 12 the power 4. Clearly, it's a fraction, but only numerator is there, denominator is there, and the power is even. So it's always going to be positive no matter what, because the power is even, right? So that's the first thing. It's a continuous function. Only place it does not exist is at 4. So except for x for more than 4, this is continuous. F is continuous for x more than 4. So I know we are saying we have to have continuous on 1 to infinity, but even if the function is continuous most of the n values except the first few 4, right? So in this case, it's only not for continuous for 1, 2, 3, and 4. And we are more concerned about what happens when n approaches to infinity. So we are perfectly fine with that. Okay. So basically we're gonna have to start from 4, not from 4 onwards. So basically we need to start from 5. Okay. If the function is decreasing, if we find f prime x, that would be negative 4 by 3x minus 12 power 5 times 3. So that is clearly negative number. So therefore f is a decreasing function. So we have checked all three conditions. That means the series converges if this integral converges. But in place of 1, we are gonna put 5. Okay. Why are we putting 5? Because until 4, at 4, the function is not continuous. Okay. So 5 to infinity. Because it's infinity, we need to write limit b approaches to infinity, 5 to infinity. The function is integral of the function would be power add. Here we'll have b power add. The power is negative 4, so it'll be negative 4 plus 3, negative 3 by negative 3 times 3 because of this coefficient from 5 to b. Limit b approaches to infinity. When I put upper limit now, minus the lower limit. When I put upper limit, it's gonna be like 1 by 3 times b minus 12 power 3. I'm gonna take negative 9 out, minus 1 by, when I put 5, 3 times 5, 15 minus 3 is 3. 15 minus 12 is 3. 3 power 3. Now you guys notice when b approaches to infinity, this becomes infinity, so the whole thing approaches to 0. So what do we have? We have 1 by 9 times 27, basically 3 the power 5 with the positive sign. The integral is finite. That means this improper integral. So what are we concluding? The improper integral converges. Okay. Now we say if the integral converges, then the series also converge. They either both converge or both diverge. So therefore, this series also converge.